Hello, I hope you're doing well. Welcome to the DP-900 Azure Data Fundamentals course. If you want to pass the DP-900 exam, then you're in the right place. This course is a complete preparation of the DP-900 Azure Data Fundamentals, and if you pass this exam, then you'll be able to call yourself DP-900 Azure Data Fundamentals Certified, and you'll be able to get a badge that you can put on your resume, which can really distinguish you from your peers. Before we start, let's see if the DP-900 is for you. This course is a great fit for candidates who have foundational knowledge of core data concepts and how they're implemented using Microsoft Azure data services. The exam is actually intended for candidates beginning to work with data in the cloud. You need to be familiar with concepts of relational and non-relational data and different types of data workloads such as transactional and analytical. And what's cool about this course is that it can be used to prepare for other Azure role-based certifications like Azure Database Administrator Associate or Azure Data Engineer Associate, but it's not really a prerequisite for any of them. But what makes this course different? The concept of this course is different in the sense that it really prepares you for the DP-900 exam. On this platform, there are two kinds of courses for this topic. The first type are regular courses that fully cover the DP-900 syllabus, while the second type are practice courses or practice tests that try to mimic real exam questions. Our course is a kind of an in-between course. It focuses on recurrent questions and tries to explain the concepts around those questions. And this way, you'll be prepared to take the exam by not memorizing the answers, but being able to answer different versions of recurrent questions. Before purchasing our course, please understand that this course will not replace standard courses that cover the full syllabus. It's more of a course that you would take before the exam as a review of most recurrent topics. And the course will give you a strong background to answer real exam questions. So what are the skills that are measured in the Microsoft DP-900 Azure Data Fundamentals? That is, what is this exam really assessing? The first skill is describing types of core data workloads, which covers 15 to 20% of the exam. It includes describing batch and streaming data and the difference between them, the characteristics of relational data, and data analytics core concepts, and it also describes data visualization, reporting, and business intelligence, as well as basic chart types such as bar charts and pie charts. Then, it talks about analytics, techniques such as descriptive analytics, diagnostic analytics, ETL, which stands for Extract, Transform, Load, and ELT, which stands for Extract, Load, Transform, as well as the concepts of data processing are also described. The second topic of the DP-900 exam is on working with relational data on Azure, and it covers 25 to 30% of the exam questions. It comprises relational data workloads, identifying the right data offering for a relational workload, and relational data structures such as tables, indexing, and views. It also talks about relational Azure data services, Azure SQL database services, including Azure SQL Database, Azure SQL Managed Instance, and Azure SQL Server on Azure Virtual Machine Database. And the third topic is about non-relational data on Azure, which covers 25 to 30% of the exam, and it talks about comparing data definition language versus data manipulation language, query relational data in Azure SQL Database, Azure Database for PostgreSQL, Azure Database for MySQL, PostgreSQL, MySQL, and Azure SQL Database. The fourth and final topic is about analytics workload on Azure, and it covers 25 to 30% of the exam questions. The student should be able to describe analytics workloads, transactional workloads, and the difference between a transactional and analytics workload, and the difference between batch and real-time. It also discusses data warehousing workloads as well as the components of a modern data warehouse and Azure data services for modern data warehousing such as Azure Data Lake, Azure Synapse Analytics, Azure Databricks, and Azure HD Insights. So if you want to take and pass your DP-900 exam, then don't wait. Go to your preferred search engine and look for the DP-900 Microsoft Azure Fundamentals exam. When you open the link, you'll find the price of the exam, which is relatively cheaper than regular Microsoft exams. It's actually only $99. This is not sponsored, I'm just saying. You could take your exam online or in a test center, and you can schedule your exam with Pearson VUE and pay the fees there. Alright, so let's delve deeper into the structure of the exam, or at least the first section of the exam. The first set of skills in the DP-900 exam is focused on core data. By the time you're taking the DP-900 exam, you should be able to describe types of core data workloads, such as batch data and streaming data and the difference between them. You should also be able to describe data visualization. This includes reporting, business intelligence, and so on. You will also be expected to know about basic chart types, such as bar charts and pie charts, and you should also be able to describe ELT, which is extract, load, and transform, and ETL processing, which is extract, transform, and load, as well as describing analytics techniques such as descriptive, diagnostic, predictive, prescriptive, and cognitive analytics. Let's start our journey with the most recurrent topics in the DP-900 Azure Database Fundamentals by talking about batch processing. Batch processing is the processing of a large volume of data all at once. The data easily consists of millions of records for a day, and it can be stored in a variety of ways. So a record, a file, etc. The jobs are typically compiled simultaneously in a non-stop sequential order. In batch processing, latency is expected, and latency is the delay that may result from processing large amounts of data. In real life, some batch processes may take minutes, some others may take hours or even days to process a large amounts of data. A batch process can output data to many types of storage, for example, a file store such as text files, a relational database such as SQL Server, or a NoSQL database such as MongoDB. Alright, so what's the difference between batch processing and streaming? We'll split it into two parts. First, we'll talk about batch processing, and then we'll talk about streaming or stream processing. So, batch processing refers to the processing of blocks of data that we have or that have already been stored over a period of time, or it can be collecting data over time, then processing it when a certain condition is met. So an example of the first kind, which is processing of blocks of data, would be analyzing an order list that's loaded to the data warehouse every 24 hours, or analyzing historical financial data from last year. And then an example of collecting data over time, then processing it when a certain condition is met, is when we're analyzing, for example, collected network events when a security incident happens. Stream processing, on the other hand, is a big data technology that allows us to process data in real time as it arrives, and then detects conditions within a small period of time from the point of receiving the data. So basically, it allows us to feed data into analytical tools as soon as pieces of data are generated, and that way we can obtain instant analytics results. So notice here that we're using the word real-time, which is a key word in the definition of stream processing. So examples of real data processing can be that thousands of online orders are loaded to the data warehouse every second. And another is to track the real-time location from a mobile application. Now that we've gone over the differences between batch and streaming data, I'm going to give you some tips on how to answer questions on batch and streaming processing data in the DP-900 exam. So this is in the context of the exam. In general, you're going to find that the question will give you a scenario of data collection and processing. And the frequency of collection and processing is the key to the answer. So in batch processing, like we said, we're going to be talking about hours, days, months, or even years, while in streaming processing, we're going to be talking about real time and seconds. Okay, so now that we've covered batch processing and stream processing and related data, and then also tips about how to answer questions relating to those, we're going to move on to our next topic, which is one of the recurrent topics in the DP-900 exam, which is the visualization charts. Data visualization charts are graphical representations of data that tell a story using symbols in order to improve the understanding of large amounts of data. They have a lot of benefits because they present trends and patterns in data. Data visualization is key component in being able to gain insight into your data. It brings data to help you find key business insights quickly and effectively. It also helps make big and small data easier for us to understand and makes it easier to detect patterns, trends, and outliers in groups of data. It also helps communicate the significance of data to the business owners and managers and also decision makers. So it really is a decision maker best friend. We're going to see some of these visualization charts in the coming slides. First, we have tree maps. Tree maps are charts of colored rectangles with size representing value. They can be hierarchical, with rectangles nested within the main rectangles. The space inside each rectangle is allocated based on the value being measured, and the rectangles are arranged in size from top left being the largest to bottom right being the smallest. Tree maps are a great choice to display large amounts of hierarchical data, to show the proportions between each part and the whole, to show the pattern of distribution of the measure across each level of categories in the hierarchy, to show attributes using size and color coding, and to spot patterns, outliers, and most important contributors, and also exceptions. In our example, here we're showing the number of products sold last year ranked by category, and we can see that the home category has the most units sold. Then come the categories men's, groceries, kids, and so on. Another interesting chart is the scatter plot. A scatter plot is a chart that shows the relationship between the two values. It always has two value axes to show one set of numerical data along a horizontal axis and another set of numerical values along a vertical axis. The chart displays points at the intersection of an x and y numerical value, combining these values into single data points. These data points may be distributed evenly or unevenly, as you can see in this example, across the horizontal axis depending on the data. In the example we have here, we're showing a scatter diagram of ice cream sales versus the temperature or the outside temperature. So the local ice cream shop keeps track of how much ice cream they're selling versus the noon temperature on a specific day. The diagram shows their figures for the last 12 days. It's easy to see that warmer weather would lead to more sales. Another type of charts is a key influencers chart. A key influencer chart displays the major contributors to a selected result or value. Key influencers are a great choice to help you understand the factors that influence a key metric. So, for example, what would influence the likelihood of a customer rating being low? The customer is, in this example, can have three roles: consumer, administrator, and publisher. Being a consumer is the top factor that contributes to a low rating. Indeed, we can see that the likelihood of a rating being low increases by 2.57 times when the role of a customer is a consumer. The next concept that will most probably be part of the exam is the ELT. ELT stands for extract, load, and transform, and this process is a data pipeline used to replicate data from a source system into a target system, such as a cloud data warehouse. It basically moves raw data from a source system to a destination resource, again, such as a data warehouse. So as we said, the E stands for extraction, and this first step involves copying data from the source system, for example, a CRM. The L stands for loading, and during the loading step, the pipeline replicates data from the source into the target system, which might be a data warehouse or a data lake. The letter T stands for transformation. So once the data is in the target system, organizations can then run whatever transformations they need. And often you'll see that organizations will transform raw data in different ways for use with different data analysis tools or business processes. And since the data store used to perform the transformation is the same data store where the data is ultimately consumed, it's very important that the target data store has to be powerful enough in order to transform the data. ETL stands for extract, transform, and load, which is a data integration process that combines data from multiple data sources into a single consistent data store that is loaded into a data warehouse or other target system. ETL is often used by an organization to extract data from legacy systems. During that extraction, raw data is copied or exported from source locations to a staging area. This data can be extracted from a variety of data sources, which can be structured or unstructured. Those sources include, but are not limited to, SQL, NoSQL servers, CRM and ERP systems, flat files, email, web pages, and so on. The second step is transforming the data. Transforming the data to improve data quality and establishing consistency. In the staging area, this happens in the staging area. So the raw data undergoes data processing. Here, the data is transformed and consolidated for its intended analytical use case. This phase can involve filtering, cleansing, deduplicating, validating, and authenticating the data. This also includes performing calculations, translations, or summarizations based on the raw data, and formatting the data into tables or joined tables to match the schema of the targeted data warehouse. Third, we're loading the data into a target database. In this final step, the transformed data is moved from the staging area into a target area warehouse. Typically, this would involve an initial loading of all the data, followed by a periodic loading of incremental data changes, less often, full refreshes to erase and replace data in the warehouse. Up next, we have another very recurrent topic in the DP-900 exam, which is data analytics. The exam questions are usually about types of analytics, so let's see what these types are. First, we have descriptive analytics. This type of analytics normally helps answer questions about what has happened in the past. So normally this would be around or about historical data. Then we have diagnostic analytics, and this examines data or content to answer the question about why it happened, or why have we seen past results. Then we have predictive analytics, which basically answers the question of what should happen in the future or what would happen in the future. And then we have prescriptive analytics that tells us what action we should take. So you could think about like a prescription that's provided to you by your pharmacist in order to remedy something. So just like what actions you can take. And finally, cognitive analytics, which simply enables the analytical tool to think like a human. So let's now look into some of these analytics types in details, the ones that you can be asked about in the exam, and then give you examples on each one of them. Let's start with descriptive analytics. It's actually a commonly used form of data analysis whereby historical data is collected, organized, and then presented in a way that is easily understood. It's normally focused only on what has already happened in a specific business. Examples of descriptive analytics would include generating reports to provide a view of an organization's sales and financial data. Another example would be summarizing past events such as marketing campaigns, as well as social media usage and engagement data such as Instagram or Facebook likes. But in general, what you need to remember is the fact that descriptive analytics is focused on what happened. So what will help you remember this is the word what. So just keep that in mind for the exam. Next up, we have diagnostic analytics. Diagnostic analytics is a form of advanced analytics that basically examines data or content to answer the question of why something happened. So it's characterized by techniques such as drill down, data discovery, data mining, and correlations. Diagnostic analytics will help answer questions about why events happened. So these techniques supplement basic descriptive analytics, and they use the findings from descriptive analytics to discover the cause of these events. So some examples of diagnostic analytics would be why did sales increase last year, or why are COVID-19 cases increasing? So again, for this one, we need to remember that diagnostic analytics are about why. So just to kind of go over what we said before, for descriptive analytics, it's about what, and when it comes to diagnostic analytics, it's about why. The third type we have is prescriptive analytics. Prescriptive analytics is a combination of data, mathematical models, and various business rules to infer actions to influence future desired outcomes. Some examples would be, how do I allocate my budget to buy the maximum number of items? Or, which stock should I buy? Remember, so for this one, prescriptive analytics is about how. Let's just go over all of this. So first, we have descriptive analytics, that's about what. Diagnostic analytics, that's about why. And prescriptive analytics, that's about how. And finally, we have cognitive analytics. Cognitive analytics attempts to draw inferences from existing data and patterns, derives conclusions based on existing knowledge bases, and then adds these findings back into the knowledge base for future inferences in a self-learning feedback loop. It helps you learn from what might happen if circumstances change and how you might handle these situations. And some examples of this are transcribing an audio file. Just an FYI, audio transcription is the process of converting speech in an audio file into a written text. And this could be any recording featuring audio. So that could be an interview recording, academic research, or a video clip. Another example would be helping diagnosing illnesses. So AI-based software can tell whether a patient has a certain disease even before evident symptoms appear. In their latest research, Google proves that a neural network can be trained to detect signs of lung cancer earlier and faster than trained radiologists. Finally, the The last example is recommendations in stock market. This is where AI systems can give recommendations to investors based on previous behaviors of the stocks. The second section of the DP-900 Azure Data Fundamentals exam is about relational databases. In this section of the exam, you should be able to describe and compare different cloud solutions, such as PaaS, or Platform as a Service, IaaS, or Infrastructure as a Service, and SaaS, or Software as a Service. You should also be able to describe relational data structures, such as tables, indexes, and views, and also describe relational Azure data services. Moreover, you should be able to describe relational data workloads as well as identify the right data offering for a relational workload. You should be able to describe query techniques for data using SQL language and compare data definition language versus data manipulation language, as well as query relational data in Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. You should be able to describe the Azure SQL family of products, including Azure SQL Database, Azure SQL Managed Instance, and SQL Server on Azure virtual machines. You should be able to identify basic management tasks for relational data, provisioning and deployment of relational data services and methods for deployment, including the Azure portal, Azure Resource Manager templates, Azure PowerShell, and the Azure Command Line Interface, or CLI. You should also be able to identify data security components such as firewall, authentication, and basic connectivity issues such as accessing from on-premises, accessing from Azure VNets, or accessing from internet, authentication, and firewalls. And finally, you should be able to identify query tools such as Azure Data Studio, SQL Server Management Studio, and SQL Command Utility, etc. Let's first talk about cloud service models. I'm first going to introduce these models, and then we'll go into a little bit of detail on one of them. The first service is IaaS, or Infrastructure as a Service. This cloud service model is the closest to managing physical servers. A cloud provider will keep the hardware up to date, but operating system maintenance and network configuration is up to you as the cloud tenant. For example, we can create a VM on Azure and install our own instance of SQL Server or any other database server or software. The second cloud service model is PaaS, or Platform as a Service. This cloud service model is a managed hosting environment. The cloud provider manages the virtual machines and networking resources, and the cloud tenant deploys their applications into the managed hosting environment. For example, we can use Azure Database for SQL Server without worrying about the underlying infrastructure. Azure will give us enough resources to handle our data processing needs. The third and final model is SaaS, or Software as a Service. In this cloud service model, the cloud provider manages all aspects of the application environment, such as virtual machines, networking resources, data storage, and applications. The cloud tenant only needs to provide their data to the application managed by the cloud provider. A simple example is the use of Microsoft 365 apps, such as Microsoft Teams or Microsoft Word. Let's detail one of these three service models. Specifically, I want to look into PaaS, or Platform as a Service. The Platform as a Service cloud service model is a managed hosting environment where the cloud provider manages the virtual machines and networking resources, and the cloud tenant deploys their applications into the managed hosting environment. For example, Azure App Services provides a managed hosting environment where developers can upload their web applications without having to worry about the physical hardware and software requirements. In this model, tenants cannot control or update the operating system, and there really isn't no way to pause or stop billing for your Azure SQL database. But what's good about the PaaS model is that it has a built-in high availability feature to enable your business to continue operating during disruptions. It also has configurable scaling options, allowing to add and remove databases to an elastic pool, scaling your app from a handful of databases to thousands, all within a budget that you can control. Now that we've covered cloud service models, the second part of this section is on relational databases. Relational databases are commonly used to store and query structured data. The data is stored in entities that are in tubular form of rows and columns. Examples of that are tables of customers, products, or sales orders. Relational databases are suitable for high volume of insertions and writes in a database. Each instance of an entity is assigned a primary key that uniquely identifies it within a table. And these keys are used to create relationships between tables. For example, a customer's primary key can be referenced in a sales order record to indicate which customer placed the specific sales order. The use of keys to reference data entities enables a relational database to be normalized. This, in part, means the elimination of duplicate data values so that, for example, the details of an individual customer are stored only once instead of having her data stored every time she makes an order in the sales table. Normalization is a process of reducing redundancies in data in a database. It's a technique that is used when designing and redesigning a database. It represents a set of guidelines used to optimally design a database to reduce redundant data. Another benefit of database normalization is data integrity and consistency. A well-known example of data integrity and consistency is the referential integrity. In our example, if we try to remove a row from the customers table, let's say customer number 1, the system will not allow you to do it because there is a row in the orders table that references that specific customer's row. Some relational database management systems support clustered indexes. A clustered index physically reorganizes and sorts a table by the index key. This arrangement can improve the performance of queries further because the relational database management system doesn't have to follow references from the index to find the corresponding data in their underlying table. Our image shows the orders table with a clustered index on the customer's ID column. In the database, a view is the result set of a stored query on the data, which the database users can query just as they would in a persistent database object. It allows other users to rerun the same SQL query as much as they want. This pre-established query command is kept in the database dictionary. A view can be considered as a content defined by a query. It can also be a query of fields from many tables. For example, we can combine customer and order data from the customers and order tables. Moving on to ways to deal with data, DDL and DML. In relational databases, there are two languages, the DDL, or Data Definition Language, and DML, or Data Manipulation Language. Let's look into the difference between these two languages. DDL is Data Definition Language, which is used to define data structures and manage access to them, as well as the data contained within them. It's how we deal with the tables in the database. An example of DDL is the create command, which, as the name suggests, allows us to create database objects such as tables, indexes, and views. We have grant and revoke, which allow us to give or remove access to or from users to database objects. Alter is also a DDL command, which can be used to modify a view in a relational database by adding a new column. The drop command is used to permanently delete a database object, such as a table or view from the database. DML, on the other hand, is data manipulation language, which is used to manipulate data itself. This is how we deal with records within tables in a database. For example, insert, delete, and update are instructions in SQL. Update allows to change values of data in a database table. Join is used in a select statement to combine rows in one table with rows from another table. Let's look into some querying statements. First, we have the select statement, which is the most used and easiest SQL command. It is used, as the name suggests, to select data from a database. The data returned is stored in a result table called the result set. Here, column 1 through column n are the field names of the table that you want to select data from. In our example, we are selecting the first name and the last name from the customer's table. In relational databases, we can use some aggregate functions in the SQL statements. An aggregate function performs a calculation on a set of values and returns a single value. Aggregate functions are often used with the group by clause of the select statement. The most known aggregate functions in Transact SQL are average, or AVG, that calculates the average of a set of values. Count, which counts the number of returned rows in a select statement. Max, which returns the maximum of a set of values. Min, which returns the minimum of a set of values. And finally, sum, which calculates the sum of a set of values. In our select statement, we are selecting the maximum age of all customers. When used with a group by clause, each aggregate function produces a single value covering each group instead of a single value covering the whole table. In our example, we calculate the maximum age of customers grouped by sex, which means that we will get the maximum age for females and males separately. The next concept that we'll cover is what we call a stored procedure. It's effectively a block of code that is stored in the database. In other words, it's a group of one or more Transact SQL statements. Procedures resemble constructs in other programming languages because they can accept input parameters and return multiple values in the form of output parameters to the calling program. It contains programming statements that perform operations in the database. These include calling other procedures and returning a status value to a calling program to indicate success or failure. A simple example of a stored procedure is select all customers, a procedure that selects all customers from the customer table. Azure SQL Database is a fully managed platform as a service database engine that handles most of the database management functions such as regular upgrading, patching, backups, and monitoring without user involvement. It provides access to the latest features. With Azure SQL Database, ongoing maintenance is brought down to the minimum, allowing the tenant to focus on their own business. Azure SQL Database has a built-in high availability and managed backup service that performs backup automatically. If you have existing SQL Server licenses on your on-premises servers, you can use them on the cloud to reduce the cost. Microsoft Defender for SQL can be used with your Azure SQL Database. It includes functions that can be used to discover and mitigate potential database vulnerabilities. Defender for SQL can also detect anomalous activities that may be an indication of a threat to your databases. The second way to use SQL Server in Azure is to host a database on Azure SQL Managed Instance. Azure SQL Managed Instance is the intelligent, scalable cloud database service that combines the broadest SQL Server database engine compatibility with all the benefits of a fully managed platform as a service. What's interesting is that SQL Managed Instance allows existing SQL Server customers to lift and shift their on-premises applications to the cloud with minimal application and database changes. At the same time, SQL Managed Instance preserves all past capabilities such as automatic patching and version updates, automated backups, and high availability that drastically reduce managed overhead and total cost of ownership. Azure SQL on managed instance natively supports cross-database queries and transactions, which means that we can select data from tables on a different database than the current one. One of the topics you may have questions on in the DP-900 exam is Polybase. Polybase enables your SQL Server instance to query data with TSQL directly from Azure Blob Storage, SQL Server, Oracle, Teradata, MongoDB, Hadoop clusters, Cosmos DB, and S3 compatible object storage without separately installing client connection software. It basically allows the SQL queries to join the data from external sources to relational tables in an instance of SQL Server. A key use case for data virtualization with Polybase feature is to allow the data to stay in its original location and format. You can virtualize the external data through the Azure Synapse Analytics so that it can be queried in place like any other table in the SQL Server. This process minimizes the need for ETL processes for data movement, and this data virtualization scenario is possible with the use of Polybase connectors. Let's see now what tools can be used with Azure SQL. First, we have Azure Data Studio, which is a cross-platform database tool for data professionals using on-premises and cloud data platforms on Windows, macOS, and Linux. It provides a lightweight editor for developers with code assistance features such as IntelliSense. You can use Azure Data Studio to connect to an Azure SQL database server. Then you'll run Transact SQL statements to create and query Azure SQL databases. The Data Studio allows us to restore databases and create SQL notebooks. SQL Server Management Studio is a graphical tool for configuring, managing, and administering all components within Microsoft SQL Server. Another useful SQL database tool is Microsoft Visual Studio Code, which is a lightweight source code editor with support for development operations like debugging, task running, and version control. It aims to provide just the tools a developer would need for a quick code build debug cycle, and it leaves more complex workflows to fuller featured IDEs such as Visual Studio IDE. It has an MS SQL extension that supports connections to SQL servers and has a rich editing capability for Transact SQL. We also have SQL Server Data Tools, or SSDT, which is a modern graphical development tool for building offline SQL Server relational databases, databases in Azure SQL, analysis service data models, integration services packages, and reporting services reports. With SSDT, you can design and deploy any SQL Server content type with the same ease as you would develop an application in Visual Studio. Another interesting tool in Azure SQL Database is the command line SQL CMD. The SQL CMD utility lets you enter Transact SQL statements, system procedures, and script files at the command prompt. Another aspect of security in Azure SQL Database is the security at the database level. To be able to query a table in an Azure SQL database, you, of course, need to have access at the server level by allowing your IP address to connect to the database. You then have to have a database user, which you can easily create by using the create user command. This will create the user with a password assigned to their account. You then, as the user, need to be granted access to the table. In the example we have here, we wrote a command that grants the user called Adam access to the customers table. We have to mention here that when you first deploy Azure SQL, you specify an admin login and an associated password for that login. This administrative account is called server admin, and this account, by definition, can always connect to the database, and you'll need to create users using this account. After creating our users, we can use multi-factor authentication, or MFA, when connecting to an Azure SQL database. But in order to do that, or in order to have access to this feature, we have to authenticate our users with Azure Active Directory authentication. In the following slides, we will address security questions related to Azure SQL databases. We would like to see how we can protect our Azure SQL database. First, we will talk about Azure SQL Server level security. When you create a new server in Azure SQL database, a server-level firewall blocks all access to the public endpoint for the server by default. And to access the database, your IP address should be allowed by the firewall. By default, no external access to your SQL database will be allowed until you explicitly assign permission by creating a firewall rule. It's good practice to disallow access to the Azure SQL database from the outside networks, such as internet. In general, it's the application server that needs to be exposed to customers. And what needs to be done is creating a link between this application server and the database server. Let's now talk about another way to protect Azure databases against malicious threats. This method is called TDE, or Transparent Data Encryption. Transparent data encryption helps protect Azure SQL Database, Azure SQL Managed Instance, and Azure Synapse Analytics against the threat of malicious offline activity by encrypting data at rest. It performs real-time encryption and decryption of the database, associated backups, and transaction log files at rest without requiring changes to the application. By default, TDE is enabled for all newly deployed Azure SQL databases and must be manually enabled for older databases of Azure SQL Database. For Azure SQL Managed Instance, TDE is enabled at the instance level and newly created databases. TDE must be manually enabled for Azure Synapse Analytics. In the next slides, we will talk about exam questions related to OLTP and OLAP. I'm going to first start with OLTP, which stands for Online Transaction Processing Information Systems, which typically facilitate and manage transaction-oriented applications. OLTP systems record business interactions as they occur in the day-to-day operation of the organization and support querying of this data to make inferences. OLTP refers to processing in which the system responds immediately to user requests. An automated teller machine, or ATM, for a bank is an example of a commercial transaction processing application. Another example is an e-commerce web application that reads and writes to an Azure SQL database. Online transaction processing applications have high throughput and are insert or update intensive in database management. These applications are used concurrently by hundreds of users, and the key goals of OLTP applications are availability, speed, concurrency, and recoverability. OLTP is characterized by heavy writes and moderate reads because a lot of transactions are written to the database every day, while reads are moderate. It's also characterized by schema on read. In schema on read, data is applied to a plan or a schema as it is pulled out of a stored location rather than as it goes in. It's highly normalized and preserves high integrity, and that's because we need to efficiently process and store business transactions and immediately make them available to client applications in a consistent manner. Azure supports OLTP through a range of database services such as the following. Azure SQL, which is a platform as a service solution where the user does not need to care about the underlying infrastructure. SQL Server in an Azure virtual machine where the user needs to install the SQL database server on a virtual machine and fully manages it. Azure Database for MySQL and Azure Database for PostgreSQL, and these two databases are the most used open source database solutions. The other type of processing is OLAP, or Online Analytical Processing. OLAP is a technology that organizes large business databases and supports complex analysis. It can be used to perform complex analytical queries without negatively affecting transactional systems. The databases that are used for OLTP were not designed for analysis. Therefore, retrieving answers from these databases is costly in terms of both time and effort. OLAP systems, however, were designed to help extract this business intelligence information from the data in a highly performant way, and this is because OLAP databases are optimized for heavy read, low write workloads. OLTP uses a semantic model. Semantic modeling provides a level of abstraction over the database schema so that users don't need to know the underlying data structures. Let's look into an example to clarify this. An organization has data stored in a large database. It wants to make this data available to business users and customers to create their reports and do some analysis. One option is just to give those users direct access to the database. However, there are several drawbacks of doing this, including managing security and controlling access, as well as the design of the database, including the names of tables and columns, which may be hard for users to understand. Users would need to know which tables to query, how those tables should be joined, and other business logic that must be applied to get the correct results. Users would also need to know a query language such as SQL even to get started. So typically, this leads to multiple users reporting the same metrics but with different results. Another option is to encapsulate all of the information that users need into a semantic model. The semantic model can be more easily queried by users with a reporting tool of their choice. The data provided by the semantic model is pulled from a data warehouse, ensuring that all users see a single version of the truth. The semantic model also provides friendly table and column names, relationships between tables, descriptions, calculations, and row-level security. The third topic in the DP-900 Azure Data Fundamentals is about non-relational databases on Azure. This section accounts for 25 to 30% of the exam. In this section, you should be able to describe the characteristics of non-relational data, the types of non-relational and NoSQL data. You should also be able to recommend the correct data store and determine when to use non-relational data. You should also be able to describe non-relational data offerings on Azure, identify Azure data services for non-relational workloads, describe Azure Cosmos DB APIs, Azure Table Storage, Azure Blob Storage, and Azure File Storage. You should also be able to identify basic management tasks for non-relational data, provisioning and deployment of non-relational data services. You should also be able to explain a method for deployment, including ARM templates, Azure Portal, Azure PowerShell, and the Azure Command Line interface. You should be able to identify data security components such as firewall, authentication, and encryption. You should be able to identify the basic connectivity issues such as accessing from on-premises, access with Azure VNets, access from the internet, authentication, and firewalls. And finally, you should be able to identify management tools for non-relational data. Let's start with different types of non-relational data. The first type is JSON object. The term JSON stands for JavaScript Object Notation. It's the format used by JavaScript applications to store data in memory, but it can also be used to read and write documents to and from files. A JSON document is enclosed in curly brackets. Each field has a name or a label, followed by a colon, and then the value of the field. Fields can contain simple values or subdocuments, each starting and ending with curly brackets, of course, and fields can also have multiple values, held as arrays and surrounded with square brackets. Literals, or fixed values, in a field are enclosed in quotes, and fields are separated with commas. In our example here, patient is a root object, telephone would be a nested object that contains a home phone number, a business phone, and a cell phone number, while address is a nested array. Another type of non-relational data types is the key value store. Key value stores associate each data value with a unique key. Most key value stores only support simple query, insert, and delete operations. To modify a value, either partially or completely, an application must overwrite the existing data for the entire value. In most implementations, reading or writing a single value is an atomic operation. An application can store arbitrary data as a set of values, and any schema information must be provided by the application. The key value store simply retrieves or stores the value by key. Key value stores are highly optimized for applications performing simple lookups, but they're less suitable if you need to query data across different key value stores. Key value stores also are not very optimized for querying by value. It's also important to note that a single key value store can be extremely scalable, as the data store can easily distribute data across multiple nodes on separate machines. We also have columnar data stores, which are conceptually very similar to the relational model, where the data is stored in rows and columns, but in this case, the columns are divided into groups known as column families. The columns are logically related to each other, and they are known as wide column data stores. The columns can vary by individual rows, and they are scalable, and update and delete operations are rarely performed in this data store. In our example here, we're storing customer data in a columnar model where we have two column families. The first column family is identity, which has the first name and the last name, and the second one has contact info, which has phone number and email. Another data type is time series, and time series data, as the name suggests, is a set of values organized by time. Time series databases typically collect large amounts of data in real time from a large number of sources. Updates are normally rare, and deletes are often done as bulk operations. Although the records written to a time series database are generally small, there are often a large number of records, and the total data size can grow rapidly. An example can be a data store for internet-connected temperature sensors. The collected data will be used to analyze temperature trends, and time series data type is the most suitable to store such data. Another model of data stores in Azure is graph databases. Graph databases natively support analysis of relationships between entities, and a graph database stores two types of information: nodes and edges. Edges specify relationships between nodes, and nodes and edges can have properties that provide information about the node or edge, similar to columns in a table. Edges can also have a direction indicating the nature of the relationship. Our example here shows an organization's personnel database structured as a graph. The entities are employees and departments, and the edges indicate reporting relationships and the departments in which employees work. This structure makes it straightforward to perform queries, such as finding all employees who report directly or indirectly to Sarah, or who works in the same department as John. In the next slides, we will talk about non-relational data offerings on Azure and identify Azure data services for non-relational workloads. The first service is Azure Files. Azure Files offers fully managed file shares in the cloud that are accessible via the industry standard Server Message Block (SMB) protocol or Network File System (NFS) protocol. Azure Files file shares can be mounted concurrently by cloud or on-premises deployments. SMB Azure file shares are accessible from Windows, Linux, and Mac OS clients, while NFS Azure file shares are only accessible from Linux and Mac OS clients. Additionally, SMB Azure file shares can be cached on Windows servers with Azure File Sync for fast access near where the data is being used. Another non-relational database service that Azure provides is table storage. Azure Table Storage is a service that stores non-relational structured data, also known as structured NoSQL data, into the cloud, providing a key attribute store. Access to the table storage data is fast and cost-effective for many types of applications, and is typically lower in cost than traditional SQL for similar volumes of data. You can store any number of entities in a table, and a storage account may contain any number of tables up to the capacity limit of the storage account. Table storage contains the following components. First, accounts. So all access to Azure storage is done through a storage account. Second, table. So a table is a collection of entities, and tables don't enforce a schema on entities, which means a single table can contain entities that have different sets of properties. Third, entity. An entity is a set of properties similar to a database row. Fourth, properties. A property is a name-value pair. Each entity can include up to 252 or 252 properties to a stored data. And to create an Azure resource to store data in Azure Table Storage, we need to run the command az storage account create. The next non-relational data type is object storage. Object storage is optimized for storing and retrieving large binary objects such as images, files, video and audio streams, large application data objects and documents, and virtual machine disk images. Large data files are also popularly used in this model, for example, delimited files such as CSV, Parquet, and ORC, and object stores can manage extremely large amounts of unstructured data. The data store stores data, some metadata, and a unique ID for each file. There is also documents. So a document database stores a collection of documents where each document consists of named fields and data. The data can be simple values or complex elements such as lists and child collections. In simple words, document is a non-relational data store that supports a flexible schema, stores data such as JSON files, and stores all the data of foreign entity in the same document. Documents are retrieved by unique keys. Typically, a document contains the data for a single entity, such as a customer or an order, and a document may contain information that would be spread across several relational tables in an RDBMS. Documents don't need to have the same structure. Applications can store different data in documents as business requirements change. Azure Cosmos DB is a fully managed NoSQL database for modern app development. It's designed with low latency and high availability in mind, and to respond in real time to large changes in usage at peak hours. As a fully managed service, Azure Cosmos DB takes database administration off your hands with automatic management, updates, and patching, and it also handles capacity management with cost-effective serverless and automatic scaling options that respond to application needs to match capacity with demand. Azure Cosmos DB uses partitioning to scale individual containers in a database to meet the performance needs of your application. In partitioning, the items in a container are divided into distinct subsets called logical partitions. These logical partitions are formed based on the value of a partition key that is associated with each item in a container. The fourth and final skill in the DP-900 Azure Data Fundamentals is the ability to describe an analytics workload on Azure, which accounts for 25 to 30% of the exam questions. Here, you should be able to describe an analytics and transactional workload and the difference between them. You should also be able to describe the difference between batch and real-time. You should also be able to describe data warehousing workload, determine when a data warehouse solution is needed, and the components of a modern data warehouse. You should also be able to describe Azure Data Services for modern data warehousing, such as Azure Data Lake Storage Gen 2, Azure Synapse Analytics, Azure Databricks, and Azure HD Insight. You should have some knowledge on modern data warehousing architecture and workload. You should also be able to describe data ingestion and processing on Azure and common practices for data loading. And you should be able to describe the components of Azure Data Factory, such as pipeline, activities, etc. Finally, you need to be aware of data visualization in Microsoft Power BI and the role of paginated reporting, the role of interactive reports, and the role of dashboards, as well as the workflow in Power BI. One of the concepts that will be subject for questions in the DP-900 exam is the star schema. A star schema separates business process data into facts, which hold the measurable quantitative data about a business, and dimensions, which are descriptive attributes related to fact data. A fact table is used in the dimensional model in a data warehouse design. It's found at the center of a star schema or a snowflake schema surrounded by dimension tables. A fact table consists of facts of a particular business process, for example, sales revenue by month by product, and facts are also known as measurements or metrics, where a fact table record captures a measurement or a metric. The following is an example of a fact table. In the schema below, we have a fact table called fact sales that has a grain that gives us the number of units sold by date, by store, and product. All the other tables, such as dim date, dim store, and dim product, are dimension tables. In the Azure Data Analytics part of the DP-900 Azure Data Fundamentals exam, a lot of candidates get confused with the number of Azure Data Services, such as Azure Data Factory, Azure Data Lake, Azure HD Insight, Azure Databricks, and Azure Synapse Analytics. So in the next slide, we will see where each of these services fit in the Data Azure Services whole picture. Let's say we have an organization with a huge amount of data of many types. This data can be structured, semi-structured, and unstructured, such as relational databases, JSON, graph databases, and so on. And let's say that the organization needs to create some BI dashboards and reports to help in decision making using Power BI, for example. The challenge here is that the data cannot be used directly by Power BI because it's simply not in the right format. The data needs to come from a data warehouse so we can fetch it and present it in form of visuals. And this is where Azure Synapse Analytics comes in, since it has data warehousing capabilities. In fact, the current version of Azure Synapse is the evolution of Azure SQL Data Warehouse product. Azure Synapse Analytics can prepare the data and store it, so then Power BI can read it and produce dashboards and reports. But before warehousing this data, where are we getting this data from? So before reaching the data warehouse, the data has to be cleaned by removing duplicates, reformatting, etc. And so here we're talking about transforming or transformation of the data. So which Azure service does this? It's actually Azure HD Insight. Azure HD Insight is a managed full-spectrum open-source analytics service in the cloud for enterprises. And with HD Insight, you can use open-source frameworks such as Hadoop, Apache Spark, Apache Hive, LLaP, Apache Kafka, Apache Storm, R, and more in your Azure environment. Here, we can use HD Insight to transform the data. Another Azure service that can perform data transformation is Databricks. Azure Databricks is a data analytics platform optimized for the Microsoft Azure Cloud Services platform. One of the environments offered by Azure Databricks is Databricks SQL. Databricks SQL provides an easy-to-use platform for analysts who want to run SQL queries on their data lake. So before the data gets transformed and then warehoused and then used in Power BI, it needs to be stored in a data lake. Azure Data Lake service is based on Cosmos, which is used to store and process data for applications such as Azure, Ad Center, Bing, MSN, Skype, and Windows Live. And Azure Data Lake Store allows users to store structured, semi-structured, and unstructured data produced by relational databases such as JSON files, graph databases, key value, and so on. In fact, what we're doing here is no more than the ETL process that we've talked about before, where we're extracting the data from a data lake, transforming it using HD Insights or Databricks into Synapse Data Warehouse, and then loading it into Power BI. Then the question is raised about who is managing all of these services. Here, Azure Data Factory comes into play. Azure Data Factory orchestrates the movement and transformation of data between various data stores and compute resources. You can create and schedule data-driven workflows called pipelines that can ingest data and move it between disparate data stores, and Azure Data Factory provides a UI to create the data movement workflows. The first service is Azure Data Lake. Azure Data Lake is a cloud platform designed to support big data analytics. It provides unlimited storage for structured, semi-structured, or unstructured data, and it can be used to store any type of data of any size. There's also Azure Data Lake Storage Gen 2, which implements an access control model that supports both Azure Role-Based Access Control, or Azure RBAC, and POSIX-like control lists, or ACLs. Azure Synapse Analytics is a limitless analytics service that brings together data integration, enterprise data warehousing, and big data analytics. It gives you the freedom to query data on your own terms, using either serverless or dedicated options at scale. Azure Synapse brings these worlds together with a unified experience to ingest, explore, prepare, transform, manage, and serve data for immediate BI and machine learning needs. Azure Synapse uses massively parallel processing, or MPP database technology, which allows to manage analytical workloads and aggregate and process large volumes of data efficiently. In contrast to transactional databases, which store rows in a table as an object, MPP databases store each column as an object. To use massively parallel processing database technology, Azure Synapse distributes processing across compute nodes. Compute is separate from storage, which enables you to scale compute independently of the data in your system. You can use the Azure portal to pause and resume the dedicated SQL pool compute resources. And pausing the data warehouse pauses compute. If your data warehouse was paused for the entire hour, you will not be charged compute during that hour. Microsoft SQL Server Management Studio, or SSMS, can be used to query Azure Synapse Analytics data warehouse. Azure Data Factory is Azure's cloud ETL service for scale-out, serverless data integration and data transformation. It offers a code-free UI for intuitive authoring and single pane of glass monitoring and management. It's a fully managed service, so you don't have to worry about infrastructure management. A data factory has many components, and one of them are pipelines. And a data factory might have one or more pipelines. A pipeline is a logical group of activities that perform a unit of work, and together the activities in a pipeline perform a task. For example, a pipeline can contain a group of activities that ingest data from an Azure blob, then runs a Hive query on an HD Insight cluster to partition the data, and an Azure Data Factory pipeline can execute other pipelines. The benefit of this is that the pipeline allows you to manage the activities as a set instead of managing each one individually. The activities in a pipeline can be chained together to operate sequentially, or they can operate independently in parallel. Another component of a data factory are datasets. They represent data structures within the data store, which simply point to or reference the data that you want to use in your activities as inputs or outputs. Linked services are much like connection strings, which define the connection information that's needed for Data Factory to connect to external resources. Think of it this way. A linked service defines the connection to the data source, and a data set represents the structure of the data. For example, an Azure Storage Linked service specifies a connection string to connect to the Azure Storage account. Additionally, an Azure Blob dataset specifies the blob container and the folder that contains the data. Data Factory supports three types of activities: data movement activities, data transformation activities, and control activities. Activities represent a processing step in a pipeline. For example, you might use a copy activity to copy data from one data store to another data store. A pipeline could contain a set of activities that ingest and clean log data and then kick off a mapping data flow to analyze the log data. A lookup activity can be used to read or look up a record, table name, or value from any external source, and this output can further be referenced by succeeding activities. Let's now talk about Power BI, which is an important business intelligence tool. Power BI is an interactive data visualization software product developed by Microsoft. It's a collection of software services, apps, and connectors that work together to turn unrelated sources of data into coherent, visually immersive, and interactive insights. Power BI provides a cloud-based service known as Power BI Services, along with a desktop-based interface called Power BI Desktop. Power BI Service is a software-as-a-service-based online service. This was formerly known as Power BI for Office 365, but now it's referred to as PowerBI.com or simply Power BI. Power BI Desktop is a Windows desktop-based application for PCs and desktops, primarily for designing and publishing reports to the service. A Power BI dashboard is a single report page, often called a canvas, that tells a story through visualizations. Because it's limited to one page, a well-designed dashboard contains only the highlights of the story, and readers can view related reports for the details. Dashboards are a feature of the Power BI service only, so they're not available in the Power BI desktop. And although you can't create dashboards on mobile devices, you can view and share them on there. Dashboards can display visualizations from many data sources such as SQL Server and Excel, and it can also display visualizations from many datasets. A Power BI report is a multi-perspective window into a dataset with visuals that represent different findings and insights from that dataset. A report can have a single visual or pages full of visuals. Power BI reports provide an interactive graphical interface, depict various key performance indicators, and support data exploration by using drill down. Paginated reports in Power BI now allow users to generate fixed layout documents optimized for printing and archiving, such as PDF and Word files.